Hello everybody, I hope everybody's having an amazing weekend. It is your boy Trix, and today we are going to be doing PngMe. I'm just going to get the Git repo set up and I'll be right with you. So, I just need to make a new repo. There we are. The owner is going to be me. PNG, whoops, me. There we are. Description I'll leave for now. I won't add a readme. I won't add that. I won't add that yet. Repo. There we are. Okay, so whoops, I meant master. Okay, for right now, this should be enough. I'll just go with this for now. Okay, so this question comes up weekly. So the book is basically what Wrestlings is about. It just takes you through the book and through each chapter. As we finished Wrestlings, we can start this now. Question comes up weekly in online Rust discussions. To answer this question, I'll always make something, and that's followed by a list of cool projects. Yes, that's nearly every language where it's like, hey, I've finished reading the documentation, what should I do next? Someone's like, build something, but this is a great answer for some people, but others might be looking for some more direction. Yes, I get decision fatigue from the amount of things you could do or could build. And it's like, for example, Rust Rogue. Yes, I could build it, but it does not mean that the quality of the learning that I would be doing would be as good as it would for me as it would be for someone else. Someone else might like that style of tutorial, whereas I don't particularly like that style of tutorial, which is why I prefer something like PngMe, which is what we're going to go into. This guide is intended to fill the gap between heavily directed beginner tutorial and work on your own projects. The primary goal is here is to get you writing code. The second goal is to get you reading documentation. If you haven't read the Rust programming language yet, I highly encourage you to do so before attempting this project. This guide does not cover any language features. That's fine. So what are we going to be making? We're making a command line program that lets you hide secret messages in PNG files. Your program will have 4 commands. Encode a message into a PNG file. So that will just involve reading in a file, reading in a text string or something, and then writing that text string to an empty position in that PNG file, and then writing that PNG file back to its location or writing it to an output location. Decoding a message stored in a PNG file, basically doing the opposite and doing the reverse. Reading in a file, then once you've read in the file, you would check the position that you believe you would have written to, and then you would just read that into a string or something and then output that to the console. Remove the message from PNG file. That would be, again, decoding the message and then choosing that after you've read the message, would you like to delete it? If you remove the message, then you'll just remove that block of bytes from the PNG file and then write it to an output file. Print a list of PNG chunks that can be searched for messages. Not entirely sure what that is. I'm assuming it will just print all of the chunks that could contain a message. If that sounds scary and beyond your ability, then this guide is definitely for you. Yes. If you know how to write code and you know how your Rust basics, you can totally do this. We're not going to implement any sort of image decoding. It's surprisingly simple. Well, that's upsetting. I wanted to do some image decoding, but that's fine, I guess. Unlike many of the other tutorials you may have worked through, I will not provide any completed code. Nice. If you need extra help, there are hints for each chapter along with code stubs that can get you started. The first 3 chapters come with comprehensive unit tests that will ensure your code has features it needs. You'll use your unit tested code to complete the remaining chapters. This is supposed to be your project, not mine. You can use as much or as little of this material as you want. You know your learning style better than I do, so do that and do what works best for you. You don't need to follow my suggestions or click my links or use my unit tests if you don't want to, but you can always come back to them if you get stuck. I'll give you links to documentation for everything I used in my own implementation of this project, but it's up to you to figure out how to use what you've read. While you're reading those docs, dig around a little bit and see what else is available. Rust standard library types provide a ton of useful functionality that you might like something else, and you might like something else more than what I linked. If you want a more regimented plan, here it is. For each chapter, read the intro, read the requirements, copy the unit test into your project, read the relevant section of the PNG spec, write your code and try pass the tests. If you get stuck, check your provided list of resources. If you're still stuck, check out the hint page for that chapter. If you can't figure it out, ask the internet. The Rust community is very helpful. So, setup. Create a new binary project using cargo new bin PngMe. Okay, so what's the recursive? Anyway. My implementation called PngMe because I think I'm clever. Feel free to name yours whatever you want. Copy the following code into your main.rs, okay? So, this is going to be our main.rs. There we go. Your project will need to match this module structure in order to for unit tests to pass. So the easiest way to set this up is to make a separate file for each module. For example, to create a file called chunk.rs in your SRC folder, the code in this file will be your chunk module. See the module chapters in the book for more info. So we're going to have, we're going to have a args.rs, we're going to have a chunk.rs, a chunk type.rs, a commands.rs, and a png.rs. png, commands, chunk type, chunk, and args. Cool. I provided error and result type aliases that will make it easy to use the question mark operator in your code. My own implementation uses the anyhow create for error handling. It's got some nice macros like bail that make it easy to return errors in the middle of a function. If you're reading this in the future, we've all probably moved on from anyhow to some fancy error handling crate. You do you. That's fine. Okay, here we go. So we are going to go chapter by chapter. Okay, so we got chunk types, chunks, PNG files, command line, using code to write more code, and then next steps. And next steps. And then hints and stuff. So we're going to tackle chapter 1 first. I like navy. There we go. The next 3 chapters will have you implement a basic PNG file. PNG files are essentially just a list of chunks, each containing their own data. Kind of makes sense. If you've looked at like audio files and stuff, it's basically the same. You just have chunks of audio information with like a frame header and then the actual audio data to play. The frame header just tells you about the size of the actual audio that you're going to be playing and some extra information about the audio that you're going to be playing throughout, right? Each chunk has a type that can be represented as a 4-character string. Okay. There are standard chunk types for things like image data, but there's no rules that would prevent you from inserting your own chunks with whatever data you want. We can even tell PNG decoders to ignore our chunks depending on how we capitalize our chunk types. In this chapter, we'll be implementing chunk types. They are pretty easy. These are pretty easy since they're essentially just 4 alphabetical characters. Chunk types should always be valid chunks. Should not be possible to construct an invalid chunk type using your public interface. PNG file structure spec will tell you what a valid chunk type looks like. Okay. I keep saying that chunk types are strings, but you'll want to think about them in terms of bytes, yeah. If you've never worked directly with bytes before, it's not that scary. If you have worked directly with bytes before, you can skip to the assignment section. I have, but I'm going to keep reading it a bit. A bit is a 0 or 1, yeah. A byte is 8 bits, yeah. In decimal notation, a byte is a number in the range of 0 to 255, yeah. I was talking about this the other day with RGB values, that everything is just represented by 0 to 255. You have probably heard that computers only understand 1s and 0s. Well, that's kind of true. They generally communicate using bytes. In Rust, bytes are represented by the type U8. But yes, ish. Memory segments are stored as bytes, but actual instructions to execute are stored as assembly language or machine code language, which technically isn't just bytes. It does have instructions and stuff, which yeah, it does get converted to bytes. So, bytes are fun because their meaning is usually open to interpretation. We've already seen that individual bytes can be represented as 8 individual bits or as a number from 0 to 255. They can also be interpreted in groups. A 32-bit integer is 4 bytes. Rust even gives you a function to make a U32 from 4 bytes using U32 from B bytes 1, 2, 3, 4. A Rust string is just a vec of U8. whose bytes have been validated as UTF-8. Guess what the 8 in UTF-8 stands for, which is just 8 bits. Now let's make some chunks. Using that spec, implement chunk types. Don't worry about implementing any specific chunk types, you only need to store a valid PNG chunk type. You don't have to implement a full chunk object either. We'll do that in the next chapter. This is just before byte chunk type description in section 3.3 of the link above. You need to provide methods that return the chunk type in bytes. You check the validity of the entire chunk type and check the special meaning or capitalization for each of the 4 bytes. Method signatures are provided below. You also need to implement a few standard libraries. Copy the units below and paste them at the bottom of your chunk type RS. So here are the unit tests. Okay. There we go. Okay. Write a chunk type struct with your implementation of PNG chunk types. So I need a struct of chunk type, right? So it's just going to be... Let me just cd into rustlings from that. So I just need a struct. Quotes. There we are. So that's a struct, right? With my implementation of chunk types. So in here, I could just make a struct of how would I do this? So let's just have a look. It means 3.3, right? So chunk type codes are assigned to... Okay, let me just read the whole thing. So upper and lowercase ASCII letters. So what I could do is, in here, when I'm validating the values, I just need to make sure that each what's the word? So when you have an integer, you just need to verify that it is in the valid ASCII range. So you just iterate over each integer and just do a check that if the integer is between a to z capital letters, a to z lowercase, 65 to 90, and then 97 to 122, it's fine, right? Same thing for the string. You would just convert the string character to a bit, and that bit will be positive or negative. As long as that bit that is positive is within that range of valid ASCII letters as an integer, it's fine. So you would just need to know what the valid integers for ASCII letters for those ranges is valid. That's all. Hang on. So it only has try and from, right? So technically, what I have right now is okay. Then, what we want is, we want an implementation of chunk type, right? So if I go to Wrestlings and then look at implementations, import struct, okay. Then I just need to look at conversions, I think. So try from for chunk type, from str, then display, okay. So There we go. So let me get the first one working right. So all that does is try from dot unwrap just returns. Let me have a look at Rust try from. There we are. So I got a struct, right? So we got import try from for a u8 of 4 for chunk type, right? Then up here I don't even need these brackets. There we are. So in here all this is going to have is a public function fn try from with a array of u8 4, and that is going to return a result of self error, right? And in here we're just going to have type error equals and star static str. Okay, so in here we're just going to if we just return OK of array, what happens? Hang on. Ah. There we are. So now I just need to implement bytes. I'm looking for one with a function in it, but it looks like I'm just gonna have to roll with it. Yeah, so I'm gonna have to make an implementation for chunk type with a bytes method. So inside here, I'll just have a function bytes with and self, which returns a u8 of 4. Interesting. think that's it for that one. Oh, it needs a public function. Well, that makes sense, doesn't it? Oh, honestly. That's pub. This is pub. There we are. That shouldn't mean anything. There we are. Let me just comment this out again. There we are. So, so I have name, right? You'd have red, green, blue, green, blue, blue, 1, 0. I think I know how to do this. So right now I'm having code, then all I need to do is inside here, change this for this, change this for this, there we are. Unknown field. Oh, whoops. So on line 92. Okay. Okay. There we go. So that makes the first bit, right? So all it does is it just takes the U8, chucks it in, makes a code from it, and that's it, right? So the actual bytes should be equal to expected bytes. That just makes sense because all we're doing is just wrapping the chunk type that's passed through as a code, which is just the chunk code inside that chunk type struct. Then we're just returning the same thing in bytes. We're just returning that code in on the bytes function. So when it extracts it, it just gets that. That's fine. So now this one is to use try from and then from string, sorry. So from string, where is it? Is here we are. So from string, impl from str for chunk type. Let me just go 11 up. There we are. So in here we have something very similar to this. Which I just print in here. There we are, and this is from str. So this takes a string there we go. Now all it needs to do is convert each character in the string to the chunk type, right? So split string rust so inside here so we have let parts equal s dot split on each character, right? So that splits on each character. Then all we need to do is split, then first collect as U8. U8 this. Missing error in implementation. Hang on. Not a member of trait from Straw. Ah. Missing error in implementation. Error in implementation. Found and U8. I could call .unwrap on it, right? So in here, type error. There we go. Must implement partial EQ. in 2 bites. Mm-hmm. Yes, but it returns a and U8. It doesn't return you a U8 or fixed size. Oh yeah. would I convert this? Because I got it as a U8 array right now, but not a fixed U8. Vector of U8. Oh, as slice. Why can't I figure this out? Oh, I can just call collect. Dot it up. Yeah, it's as bytes, but I keep getting the wrong value. Derive partial EQ. How? I'm using as bytes. But when I try to convert to a U8 of length 4, I can't. Try into. Did it do it? It done it? Should arrive partially Q, debug. There we are. Nice. How far we've been going for an hour and 21. So now we got a couple more tests left. We got test chunk type is critical, not critical. We got some more. We definitely have some more. But I'm probably gonna call it there. This has been fun. And figuring out this try into and unwrap was very interesting. Just because I don't know why it wasn't working. But anyway, I do think it would be better if I did... If I turn this pub struct into, instead of having a code attribute, had a comma, had a actual argument that's just there. So like, I think what I can do is, I can do this, right? Nope. Anyway, for now, just gonna use my normal readme generator. I think it's PNG, yep, PngMe. There we are. Got no logo. PngMe. Badges, I have none. actually forgot about this, genuinely, because it's been a long time since I've installed Rust and Rust Up. Well, first step is just cloning the repo, isn't it? Clone the repo. Cargo build. Cargo run. That's pretty much it. That's the lowercase cargo. There we go. Usage. Don't worry, having usage instructions. I do not have a roadmap. Yeah, that's fine. License. Authors. Just myself, isn't it? So I don't really need an author. And then acknowledgements. Sorry whoever made this utility, I am not going to be acknowledging you. But I will be acknowledging the original creator. What was his name again? It was... I need to remember how to get to his GitHub. Oof. Nah. It'll be... There we are. Cool. So there we go. So if I refresh this, there is everything that's initially here. So if I... How are 2 people watching this? How? I literally made the repo. Okay, fair enough. Cool. So inside PngMe, you'll see whatever, right? So inside SLC, you'll have everything. I just need to... I don't want to add a license. If anything, I'm going to... Actually, what I can do is... Pickle... Where is Pickle Nerd? I can grab his license and just put it on the repository. I do not want to take a... I don't want to take... what's the word? I don't want to take credit for his work. He hasn't got a license. Oh, damn. There we are. there we are. So if I go back up, go into PngMe. Now only the important stuff's left. Nice. So that was 4 commit messages just to undo my mess up. Always include a git ignore, guys. I do want to add a thing to Pickle Nerd's PngMe book. I would love for him to include a license, just because I do not think it's okay for me to license this without him having a license on there. I would really prefer if he did have a license, so I'm just gonna make an issue. Hang on, let me just check that no one else has made an issue. Licensing, license. Is the right word accreditation? How would you like to be accredited? If that makes sense. I just started working on PngMe, or if you've been licensed project. I think lots of people have probably already started implementing their own version of PngMe, but I was wondering how you would like to be accredited. License. Could you add a license? There we go. What's the right spelling? License. Driving license. I spelled it the American way, I'm guessing. Sorry. License. But I was wondering how you would like to be accredited. Are you planning to license this project? I just started working on PngMe. I was wondering. I'd probably start then, but I was wondering how you would like to be accredited. Yeah, I'll just submit that. Oh, also, I was going to talk about this. Oh, I'm running a bit late on what I'm supposed to be doing today. Let me just go to audio reader. So a while back, during one of my interviews, I made this audio reader. I got bored the other day and was like, I need to refactor this because I'll show you the old version. The old version was a where is it? If I go to, let's say, add improvements from interview, this one, there we are. So if I go to this commit, I just want to, let me exit out of there. And then if I just go to, where is it? I'm pretty sure you can look at the, what's it called? There we are. You can browse the files on this commit. So this is the old version I had. This is very embarrassing. Look at this. So this was the file structure I had, right? So this was just the MP3 file, license, README, and then the actual files. Audio reader was the original one I had. When I first done the interview and was like not really sure what to do, and God, it's a big file. It is nearly 500 lines, and that is purely because I added a ton of if statements, right? And then after having one interview and like getting some feedback on this, I improved it and cut it down to about 150. So pretty good, right? But still, it kept bothering me that while at work, like, I've been learning how to do tests, I've been learning some other stuff, and then I look back at this and I'm like, I'm proud of this project because it took a lot of effort to try getting it working, but I never added tests. And like I didn't do anything fancy or whatever. So this is what it looked like, where there is no test. It's just, when I was doing this, I was literally like line by line just running it, seeing what the output was, and then like trying to figure it out. I didn't even use a debugger, right? So if I go back to code and take a look at master now, if I go into SRC, I have an actual structure now. I've got a build Gradle, just a bog standard build Gradle, just a Gradle in it, then some settings just to say the root of the project. Then inside here, I've got log4j, JUnit, SLF4j, and assert4j, just bog standard really for like testing. Then in my main, I got resources, which is just the log4j XML. If you've done logging before, you probably know what this looks like. I just grabbed a default one that I found online. Audio reader, which is literally just the same code, just now I split everything into different functions, and this is just a factory class now. It should really be called audio reader factory, but it just has static methods that you can just supply a byte buffer to, and it will just do the computation for you. I still mess up with the what's it called, with the bit shifting, just because for some reason I understand how to bit shift. Like, this is literally what bit shifting is. You just shift on that position, and then you AND with 1 so that you can only get the values that are the same, are on, right? Which is fine. Then that total, completely fine. It's just like calculating the actual value from that bit based on the position it is in the binary number. So if you're in position 1, you'll do 1 times 2 to the power 0. If you're in position 2, it's 2 times 2 to the power of 1, whatever. That's why there's the 1 minus whatever. I mean I minus whatever, because that's just the start position. So it's a little bit complicated, but not that complicated. I tried using AND bitwise operators with AND on the actual like bit positions that should be there. So 2 and 3 should just give you reading right to left. 0, 0, 1, 1, and then 0s all the way up to bit position 7, 8, depending on if you count from 0 to 7 or 1 to 8. I count 0 to 7. So that's how it should work, right? But for some reason, every time I do it, the actual calculation becomes wrong, like goes wrong, after I do MPEG audio version's fine, get layer is okay, but then bitrate and sample rate and channel mode all seem to work a little differently. Not particularly sure why. Also, this percentage 3 is just because I was a knob and forgot that, oh, I could just reorder the sample rates into the correct format, so I don't have to mod 3. I could just do it vertically instead of horizontally. It's just whatever. Anyway, tests. If I go into here, audio reader, this is just test files just to verify everything that's working. I also feel very bad that when I first done this, I just read it into a byte array. I didn't even use a byte buffer, and like you could direct allocate a byte buffer if you wanted to, and then just yeah. Anyway, this is how I got that working. Then your resources, you'll just chuck in your file that you want to test against, and you'll just test against that, right? But I'm planning to, again, lots of words, word spaghetti right now. What I'm planning to do is, I'm thinking of making a server, a web server, that you could upload a file, and then it will just execute these values on that, execute these methods on that file. So you just get the data back immediately, and it'll just return it to you in the browser. I'm planning to use like Netty and just normal Netty handlers, not anything fancy. If anybody is interested in me doing that, I'd really appreciate like someone just leaving a comment saying, hey, you want to see it happen, or like you want to see it work, because I think it'll be really cool. But yeah, I do think it'll be cool. I know lots of people aren't into the whole like, oh yeah, you're doing bitwise stuff and stuff like that. That's why I'm thinking, oh, maybe I should do a front end project soonish. But it'll be fun. I think it'll be fun. I really enjoy doing PngMe as well, just because like doing bitwise stuff is very fun. But yeah. Anyway, if anybody is interested in doing that, please leave a comment down below. Besides that, like, subscribe, enjoy the rest of your day, and peace.